Hi, this is Nat. Today we will see the counter programming in Siemens TI portal. Here we have two types of counters. One is up counter and down counter. These counter functions are used to count the number of events in a process. Let's say in a conveyor belt, if any products are moving, then if you want to count the number of units which are moving on a conveyor, then we need this counter. So now we will see this counter and its functioning. So first of all, we need to create a project. As you can see, I have already created a project in TI portal with the file name as counter, as you can see on the top. So click on this instruction followed by the empty box and again an output coil. Now we need to assign the address for these instructions. So I'm using a memory instructions M0.0, enter. Now we need to assign the name for this empty box. So as I said, we will see the counter. So CTU, so counter up, then enter. So here you can, if you want to change the name, you can, or else you can go ahead with the default name. So I'm going with the same default name. So click on OK. Here we go. So here you can see this R means the reset. So at any point, if you want to clear the counter or the counts, then you can use this reset. So this reset is a bool. So it's a boolean type. So you have to, you can provide an instruction or a normally open instruction to this particular R. So reset. So you can assign the name or the address M0.1, right? And here you go, the preset value. So here the preset value indicates, see, this output will be switched on once the counter makes the preset, the predefined counts. Say for example, if the preset value is given as 5, then if the counter gets a count of 5, then this output will be turned on, right? So initially the counter will be at 0. Okay, so the count depends on the number of events generated from this tag 1, that is from M0.0. So whenever this M0.0 switches, then you can get a count over here, right? So once you get a 5 counts, as we have given as a preset 5, once you get a 5 counts, then this output will be turned on. Okay, so just give an address to this output, that is Q0.0. Okay, then similarly, if you want to monitor the values, then you can use this CV, right? So I won't use this now. Okay, so just compile the program at the top. So compiling is done, no errors, nothing. So minimize, and now we need to open the simulation. So for that, again click on this simulation at the top, start simulation. So click on OK. Here you can see a simulation window has been opened. So before that, we need to click on load, because the program which we have created, that we need to load into this simulation, that is in the virtual environment. So click on load, then start all, finish. So now it will configure. You can see that the output is turned to green, which means now the device is ready. Okay, so you can minimize this window and then click on monitor option. So here we go, you can test the simulation. So here, right, so just modify to 1. As you can see, the count is 1. Okay, once again make it 0, and again give one more pulse, 1. So this time 2, like that. You have to make 5 counts. Okay, sorry, 0, then 1. You can see there is no output till yet, because the count has to reach to the 5, then only you get an output. So once again 0. So you have to keep on modifying this instruction 4, and now you see carefully, this time when I modify to 1, the count becomes 5. The moment when it becomes 5, you get an output. So 1, here you go. See, the output is turned on because the count has reached to the preset value. So when both are equal, you get an output, right? So this kind of function can be used in industries, or so when in packing system, when you get a required number of counts, then you can start the packing system. So this is one kind of an application where you can take, right? So once it is done, if you want to reset, if you want to clear the counter, then here you go, you can reset this. So modify to 1. So now you can see the counter has cleared. Okay, so once again you can start with another set of 5 counts, right? So this is a up counter. Okay, now similarly we can see the down counter almost similar to the up counter, just vice versa, right? So switch off the monitor, minimize. Here you can extend to one more rung. Once again, place the instructions, one open instruction, empty box, followed by an output instruction. Address the instruction M0.2, right? So here is a down counter, so C, T, D, right? So count down, you can see over here. Then just click enter. And again, if you want to change the name, you can. Otherwise, you can go ahead with the default name. I'm going with that. So OK. See, LD stands for load. So here we need to assign a switch. That is, I'm assigning as a normally open. The purpose of load is when we assign a preset value, for example 5, or let's take a small count, that is 3. Okay, so now I have assigned as a 3 for the preset value. Okay, the moment when I switch on this instruction, or when I turn on, it means load, this preset value will be loaded into the counter, which means, so hence it is a down counter. So it will decrement by 1 with respect to this tag 4, that is M0.2. The moment when this instruction, when it is closed, right, so you get a down count over here. Okay, so without loading, if you are going with this instruction, when it becomes true, then you get a negative counts. Okay, so we need to start with some point. Okay, so I have given as a 3 here. Okay, 3 is a preset value. So whenever this instruction, when it is turned on, so this counter will be loaded with this preset value. Okay, so I'm giving a address as M0.3. Okay, enter. Then here the output Q0.1. Okay, so now you just load this program into the simulation. So click on download. Okay, so load. Okay, then minimize, and now monitor. Click on monitor. Sorry, by default it is 0. Okay, now you can see now it has been loaded with the value 3. Okay, now let's check this down count. So modify to 1. So you can see the count has been decremented by 1. Hence you can see there is no output. You can see this output only when this count becomes 0. Okay, so once again modify to 0, and again modify to 1. One more down count. Repeat once again 0, and again 1. So here you go. Now it becomes 0. Now you get a output over here. Okay, so once again, if you want to start, then this load will be used. Okay, so now this counter has been set to 0. Okay, so if you want to repeat again, then you have to make it on. So modify to 1. Here you go. You can see the counter value has assigned to value 3. Okay, so once again you can repeat the same operation. So first of all, you need to modify to, sorry, modify to 0, and then modify to 1. Sorry, you have to close this load first, then only the down count will be takes place. So 0 and then 1. Here you go, you can see that it is decremented by 1. So here are the two counters. Then is one is the up counter and the down counter. So up counter, the purpose is to count for up counts, okay, and down counter the vice versa. Right. So these are the counter functions in PLCs. Thank you.